Welcome. In the next series of videos, I'm going to take you through several examples to show whether sequences are convergent or sequences are divergent. Let's take a look at this sequence. We're given the sequence b is equal to n times -1 to the nth power. So let's look at the first few terms and see what's going on. So I'm going to make this table. I'm going to start with n equals 1, 2, 3, 4, then 5. If n equals 1, we end up with 1 times -1 to the 1th power. So that's just -1. If n equals 2, this -1 here will be a positive 1 since we end up with -1 squared. So we just end up with 2. If n equals 3, we end up with 3, and then a -3 because of the power. Are you starting to see the pattern here? For 4, n equals 4, we have 4, and n equals 5, we had -5. And this continues. When n equals 6, we'll have a positive 6. When n equals 7, we'll have a -7. So it looks like the terms are oscillating back and forth between negative values and positive values. So we can make this quick sketch to get an idea of what's going on. There's n. And here we will plot the remainder of our terms. So when n equals 1, we have -1. When n equals 2, we have +2. When n equals 3, we have -3. n equals 4 takes us all the way to +4, and n equals 5 takes us to -5. So if you notice, it's going up in this direction and also down in this direction. So clearly from the table and from this graph, we can see that it's not actually going to converge to anything. Now, how can we show it? So let's take a look at its limit. If we were to ignore the positive and negative sign, that is, if we were to take the limit as n approaches infinity of the absolute value of n times -1 to the nth power, it becomes more clear what's going on here. This is the limit as n approaches infinity of n. And notice this just diverges. That is, there exists no finite limit here, since the limit of n as n approaches infinity is just infinity. So this sequence is not the sequence is not convergent, so it is divergent.